Hey everybody, and welcome to another JASP video. In this video, we're going to continue our Learn Stats module mini-series. And so in this episode, we are going to go up to Learn Stats here, click on that, and we're going to talk about sample variability. The interesting thing is that in the previous video, we talked about descriptive statistics. I really think this should move up one. So these two go with sample variability a little bit better. I think descriptive statistics is an interloper in the logical order of this set. And then descriptive statistics can go into p-values, and you can talk about confidence intervals and effect sizes, and then what kind of statistics can we do? Of course, we're going to have 4 more videos in this series for these other 4 coming up, so stay tuned for that. But in this one, we are going to talk sample variability. Now, if you are like, where's Learn Stats? I don't have that module. You got to get yourself 0.18.1, which is a hotfix that came out in September 2023 to, or maybe early October. I don't remember. Something like that. You can see that I'm recording this in early October myself. So it came out just a couple of weeks ago, and it was intended to fix some of the issues that may have been in 0.18, but also it's the introductory version of JASP for the Learn Stats module. So you got to get yourself 0.18.1. I know you love updating your JASP to get all of these new features. Now, where do you find it? Well, the good thing is all of these modules that you see up here on my top bar come pre-installed in JASP. Okay, so it's like it is like a gig to download. You know, it's a little hefty, but you get all of these in here, and all you have to do is check the box for the ones that you want on your top bar. Now, I have a bunch of these checked for things that I don't actually use or don't really know how to use, and so I probably should clean up my top bar, but be that as it may. So we're going to do Learn Stats here. So let's talk sample variability. What it's going to do, it's going to load up some defaults here. And like I said, it's very similar to my previous videos on central limit theorem and the standard error functions of this module because of its similar appearance, right? So we've got a parent distribution, we've got samples, and we're going to talk about how those samples are being changed in their variability, right? So variability is dispersion, is spread. It's telling you what a distribution looks like around a central tendency measure. So we've got variance and standard deviation, as well as a little bit of standard error when we talk about spread. So let's go through these options and talk about what's changing in our results window here as we go through this. Again, this mini series is for stats teachers to maybe integrate this module, the Learn Stats module, especially if you're teaching classical statistics, into their teaching, and maybe use this instead of a whiteboard process where your back is to everyone and you are trying to write things on the board and your writing is terrible, your drawing is terrible, yours truly cannot draw a normal distribution to save his life. So sorry to my family if they're like, gun pointed to my head, save your family by drawing a perfect normal distribution. I'm going to be like, sorry guys, this is the end of the road for me. Can't do it. So teachers of stats who may want to have a little bit more of an oomph behind what they're saying, or learners of stats who just want a little bit more to mess around with, right? Instead of always constantly writing in your notebook, you can go to JASP and start just plugging and playing, and you won't break any data because you can use these functions within Learn Stats without any data. And that's what we're doing right now. We don't have any data here. Okay, so parent distribution, that's this mother right here, okay? And so we have a normal distribution set as our commonly described or defined normal distribution, which is a mean of 0 and a standard deviation of 1. And you can change these if you want. I don't really change them in the video because we teach these 0, 1 normal distributions because they are useful. 0 is a good starting point, and 1 really gives us a nice clean y-axis here from -3 to 3. And it's, of course, a perfectly symmetrical, normally distributed graph, right? But you can change the shape if you want. You can change the shape from normal to uniform to skewed to binomial. So let's take a look at what a uniform distribution is. Of course, you don't change the standard deviation for uniform distributions. You change the range. And so here we have a uniform distribution between -0.5 and +0.5 because that is our range around a mean. We can change this to a skewed. And what it does is it'll reset back to my 0 and 1 description of this normal distribution, and then we can change where the tail is. Left is the tail is over here, right is the tail is over here, and we can have a low skew, medium skew, or high skew, or left or right, right? So that's what the skew does, and that's going to change what our sampling turns into. And then we can also have a binomial distribution, which is 2 discrete blocks represented by a green block and a blue block, and our probability by default is 0.5, but we can change that if we want to. And you can see here, if I were to flip a coin, this is a good one to show how randomness truly occurs with a coin flip or just a random number generator, right? I have recently tried to tell a class that I was playing, we were doing the Monty Hall problem as a game show, and they did not believe me that I was using a random number generator to choose the winning door, 1, 2, or 3, right? Which has a probability of 0.33. And when we sample, it's going to change the counts here. Let's say green is heads and purple is tails, right? So if I'm going to flip my coin 10 times, which is in the sample options here, we've got 10 observations. If I flip my coin 10 times, how many heads do I get? How many tails do I get? And then I'm going to do it again another 10 times. How many heads do I get? How many tails do I get? Look at this, perfect 5 and 5. And then we got another 5 and 5. And then we've got 2 and 8, 7 and 3, 6 and 4. So this is going to go until we do 10 rounds of 10 times. But it's really important that you have, you can show that, right? You can talk about this. What does this mean? How does this look when we plot distributions? And so we can change that. And we can change this to 0.33, okay? And you can see that 0.33 is my one value, and then 0.67 is my other value. And what happens when you do the Monty Hall problem? You take a door away, and you're left with 2 doors, but it's not 50-50 choice after that. It is a 0.33, 0.67 situation, 0.33, 0.67 situation, right? Still 2 outcomes, still only 2 outcomes. You either choose the winning door or you choose the losing door. So if we apply this to my Monty Hall problem here, this is the probability of staying with your door or the probability of switching. So green is staying, purple is switching. And you can see that when I do it this way, that switching yields a better outcome every time. The closest one that we get to is 4 and 6 in sample 3. I love it. I love it. I can now what I can do is I have an app here, JASP. I can open this up and I can show students that green is losing or switching or staying. Oh my God, staying, and purple is switching. And with my probability of 0.33, okay, I can also change this to 0.67 and switch my colors around, right? This is the exact opposite, right? It'll change, and then my resamples will change in case. But look at this, we've got a 5 and 5, right? So it doesn't mean that you're switching is going to guarantee that you win. I'm going, this is a far off tangent in this. All right, so let's talk about what happens with our normal distribution, shall we? Okay. So I'm gonna get new samples here, right? It's gonna be histograms. I've got my rug marks here. Show samples, show rug marks. Can't show explanatory text. This might be coming in a future update, so stay tuned. They might be working on the explanatory text, so it's grayed out right now, okay? Before I go into further sample options, I wanna talk about this parent distribution size. Infinite means infinity off to the sides, or finite, which is going to change my parent distribution. Ooh, the analysis has terminated unexpectedly. This might be, yeah, this is a bug. This is definitely a bug. We can go into the stack trace to see what happened here. Now, if you're familiar with R coding, writing the R language, I'm gonna leave this up here. You can pause. I don't know if I'll be able to, I don't know if I'll have time to report this. So if you want to report this for me, please let me know. Even if I change this to 1000, see what happens with finite. No, let's change this to binomial. Nope. Uniform. No, something's up with the finite thing. It's a bug there. Okay, let's go back to infinite. All right, that's uniform. Let's go back to normal. So number of observations per sample in our options here is 10. This is slightly different from the central limit theorem and the standard error modules or functions within the learn stats module. It's set to 30, so we could do that if we wanted to. Total samples is 10. By default, this is 100. But for the sake of your computer, by default, the first 7 are the ones that are displayed. So that's nice. That's nice. Again, I'm not sure what the set seed number is. So it does change what happens in the sample. That's something I gotta look up. And you can change this to last a range in between 2 numbers of your total sample, total number of samples, and then all, which would then display all. Now, of course, I'm not going to display all because this would take time, and I don't need to obviously do a jump cut to when they show, but I don't really want to take my time to do that. So you get the first 7 to see what's going on, and then sample 100. And then plot options are colorblind is the by default, but you have the alt, Viridis, ggplot2, and gray with the sample bin width of Sturgis. And but if you change this to manual, you can set your bin width amount, or number of bins, I should say, sorry. But here's the rub with the sample variability. I think the reason why we've got this in is to show how samples can vary, but there are no measures of variability, which is missing from this. And I think the finite is really the thing that this particular, and this is what I was going to highlight, it worked, I think it worked for me a couple of days ago, but I can't remember. The finite is where the rubber meets the road here as far as this being a teaching function, a teaching topic, is being able to change this to finite and then changing the size of your distribution. So it seems as though this is just right now, the sample variability one is a little bit of a poor man's central limit theorem, I'm going to say. So not a lot of value left in this one. I will update, I will make a new video if this module or this function gets updated with a little bit more functionality. For now, I would stick with the central limit theorem to really just show you what's happening in all of these. I really do like or unless you want to talk about binomials, in which case I freaking love it. That's amazing. Let's try to see if finite. Okay, parent distribution, population size too small. Cannot draw 100 samples with size 30 from a finite population of 1,000. Okay, so let's change that to 10,000. Yeah, and then the stack trace happens. Bummerino, man, bummerino. I'm not allowed to do more than that's too funny. They've limited it. Let's see if we can do this. Nope, and then it gets the if condition has length of greater than 1. Bummerinos. Okay. Well, I just tried to mess around with it a little bit. Again, infinite seems to work, obviously. this is the added benefit of the sample variability. Binomial distribution is not in central limit theorem. So this would be an added benefit as well. And then when they get the finite going. So that is the sample variability function within the Learn Stats module. If you have any comments, questions, suggestions, or other feedback, please leave those down in the comment section below. I'll see you in the next one. Thank you for watching. Bye.